here testing Galileo's theory of relative motion through differing angles of trajectory using 4 scenarios with 2 trucks and a tennis ball.
Our hypothesis is that if the ball is thrown directly straight from the truck, then it will be catchable in scenarios 1 and 4 and uncatchable in scenarios 2 and 3 due to the motion of the truck.
For our first scenario in our experiment, this will be our control. There will be 2 trucks sitting stationary to one another, and the person in truck 1 will simply just be tossing the ball straight across the person in truck 2. Okay, for our second scenario, there will be 2 trucks beside one another, but as soon as truck 2 starts moving, then the person in truck 2 will just throw the ball straight across. Okay, and for our second attempt, the person in truck 2 will be accelerating from 0 to 15 miles per hour while truck 1 is still sitting stationary. And as soon as truck 2 reaches 15 miles per hour, the person in truck 2 will throw the ball to truck 1.
Okay, for scenario 3, we're doing the exact same setup as scenario 2. The only thing that changes is that the person standing in the truck bed of truck 1 will be throwing the ball rather than the person standing in truck 2.
In scenario number 4, we have the same 2 trucks. Truck number 2 sitting 50 yards away from truck number 1. Truck number 2 will accelerate from 0 to 35 miles an hour. As truck number 2 accelerates past up truck number 1, the person in truck number 1 will attempt to throw it to truck number 2.
This is scenario 1 of our experiment, our control.
As you saw in the previous clip of scenario 1, which is our control, the ball was thrown from truck 1 to truck 2 and the ball was caught. This supports our hypothesis in that the ball thrown from truck 1 was directly thrown to truck 2, and which made the ball catchable.
This is scenario 2 of our experiment, attempt 1. This is scenario 2, attempt 2.
As you can see in the previous clips of scenario 2, truck number 2 moves away at a speed of 15 miles an hour from truck 1, which is stationary. Now, as truck 2 moves away, it attempts to throw the ball to truck number 1 directly perpendicular to the truck. Due to its motion in that direction, the ball ends up crossing the hood of the truck, making it impossible for this person to catch the ball. Now, in attempt 2, as the truck moves away, the person in the back of truck number 2 attempts to throw the ball at an angle back to the person in the back of the truck, making it catchable. This supports our hypothesis.
This is scenario 3, attempt 1. This is scenario 3, attempt 2.
As you can see in the previous clips of scenario number 3, truck number 2 again moves away at a speed of 15 miles an hour. Only this time, truck number 1 attempts to throw it to truck number 2. Now, due to its motion in that direction, the ball passes behind the truck as it moves in that direction, making it uncatchable for the person in the back of the truck. Now, in attempt 2 of scenario 3, the person in the back of the truck attempts to throw the ball at an angle to the person in truck number 2 as he moves away, making the ball catchable. Now, this also supports our hypothesis.
This is scenario 4. This is scenario 4, take 2.
You can see in this slow-mo clip that as Scott's truck passes Parker at 35 miles an hour, Parker throws the ball perpendicular to his truck. Because of the truck's motion, when Hunter enters Parker's line of vision, the ball maintains a straight line, making the ball uncatchable for Hunter. The truck continues to move forward as the ball is thrown straight, falling behind the truck.
As you can see in the previous clips of scenario 4, our hypothesis was refuted because when the ball was thrown from truck 1 directly to truck 2, the ball passed behind, making it uncatchable, therefore refuting our hypothesis.
In conclusion, our hypothesis was not supported, but after conducting our experiments, our results showed that in scenario 4, the ball was not catchable by throwing the ball perpendicular from truck 1 due to the motion of truck 2.